In this lecture, we'll take a look at the second approach to build a Docker image using Dockerfile. A Dockerfile is a text document that contains all the instructions users provide to assemble an image. What is an instruction? It can be, for example, installing a program, adding some source code, or specifying the command to run after the container starts up, and so on. Docker can build images automatically by reading instructions from a Docker file. Each instruction will create a new image layer to the image. Basically, instructions specify what to do when building the image. Let's go ahead and create a Docker file. A Docker file must not have any extension. It must be named as Dockerfile with capital D. The Docker file gets created. Let's open it up. We add our first instruction. From instruction. Docker runs the instruction in a Docker file in order. The first instruction must be from to specify the base image from which you are building.
Here, we just use Debian Jesse as our base image. So Debian Jesse is the argument for the from instruction.
The instruction is not case sensitive. However, convention is for them to be uppercase in order to distinguish them from arguments more easily. Let's move to the next instruction. Run instruction. Run instruction will specify a command to execute. It can be any commands you can run in a Linux terminal. Here, we do apt-get update first. Then we install git. Make sure we put -y option, because we won't be able to answer the prompt. Next, let's install vim as well. Now we have our Docker file ready. Just save the file. It is time for us to start building the Docker image. We have a new command to learn. Docker build. Docker build will build the image using instructions given in the Docker file. Here we type Docker build. Docker build takes a -t option to tag the new image we're building.
As I did in the previous lecture, I'll tag the image with my own repository name, jameslee/debian.
Docker build command also requires a path, which is the path to the build context. The path specifies where to find the files for the context of the build on the Docker daemon. For example, if we would like to copy some source code from local disk to the container, those files must exist in the build context path. Remember that daemon could be running on a remote machine, and that no parsing of the Docker file happens at the client side. When the build process gets started, Docker client would first pack all the files in the build context into a tarball, and then transfer the tarball file to the Docker daemon. What's more, by default, Docker will search for the Docker file in the root directory of the build context path. If your Docker file doesn't live in the build context path, no worries. You can tell Docker to search for a different file by providing a -f option. Here, my Docker file is at my current directory, so I can just use the current directory as the path. Now, we hit enter to start the build process. Let's go through the build output to get a better understanding about how Docker is building the image. First, it outputs sending the build context to Docker daemon. As we mentioned before, now the Docker client is transferring all the files inside the build context, which is my current folder from the local machine to the Docker daemon.
Step 1. From Debian Jesse. That is the from instruction.
As you can see, Docker is going through the instructions in the Docker file. Then step 2. Run apt-get update. Docker is executing the run instruction. It says running in, followed by a container ID.
What happens is that Docker starts a new container from the base Debian image and is executing the apt-get command in the container.
Now, when step 2 is about to finish, it prints out removing intermediate container and followed by a container ID. You might have already noticed the two container IDs are exactly the same. So Docker spins up a new container and afterwards just removes it. Let me explain to you what is happening here. Docker daemon runs each instruction inside a container. A container is a writable process that will write file system change to an image. In our case, it installs a program. Once Docker has written changes to the image and committed that image, Docker removes the container. So, for instruction, Docker creates a new container, runs the instruction, commits a new layer to the image, and removes the container. Basically, containers are ephemeral. We just use container to write image layers, and once they're finished, we get rid of them. Images are persistent and read-only. Let's continue digging through the output. Now it says step 3, apt-get install -y git, and followed by a container ID. What happens is that at the end of step 2, Docker committed our container as a new image. And it starts a new container from that image for the next instruction. Now it is installing Git. When step 3 is about to finish, it is repeating the same process to commit the intermediate container as a new image and remove the container. Let's move to step 4. It says run apt-get install -y vm, and Docker is executing the command in a new container from the image it committed in the previous instruction. Once all the steps are finished, the build completes successfully. Let's run Docker images to make sure the new image is created successfully. As we can see, the image we just built is tagged with latest because we don't specify a tag when we run the Docker build command. The new image we created is about 250 megabytes.
The base Debian image is only about 125 megabytes.
The new image almost doubled the size of the base image. So the extra layers we added by installing Git and Vim are about 125 megabytes. That's all for this lecture. I'll see you later. Hello and welcome back. In the previous lecture, we have seen how to write a Dockerfile to build an image. In this lecture, we'll learn a little bit more about the Dockerfile syntax and some best practice to write Docker files. First of all, we'll take a look at how to chain run instructions. One thing to keep in mind is that each run command will execute the command on the top writable layer of the container, and then commit the container as a new image. And that new image is used for the next step in the Docker file. So each run instruction will create a new image layer. It's recommended to chain the run instructions in Dockerfile to reduce the number of image layers it creates. I'll show you how to do this in a second. Here, we modify the Docker file. Instead of having 3 instructions, we'll do apt-get update and apt-get install git, and Vim to aggregate those 3 instructions into one. Let's save the Docker file and rebuild the image. As you see, we have only 2 build steps instead of 4, which means it is only adding one more layer on top of the base image instead of 3. Another good practice when writing the run instructions is to store multiple line arguments alphanumerically. This will help you avoid duplication of packages and make the list much easier to update. Let's say we want to install Python package as well. We need to put Python between Git and Vim so that they're sorted alphanumerically. Now we'll move on to the CMD instruction. CMD instruction specifies what command you want to run when the container starts up.
If we don't specify CMD instruction in the Docker file, Docker will use the default command defined in the base image. In our case, it is Debian Jesse, and the default command is bash.
Unlike the run instruction, the CMD instruction doesn't run when building the image. It only runs when the container starts up. You can specify the command in either exec form, which is preferred, or in shell form. Let's see this in action. We modify the Docker file. Add CMD instruction after the run instruction. Here we echo hello world. Let's rebuild the image. The build completes successfully. Now let's start a container from this image. Just copy the image ID here. See? It prints hello world. We can also overwrite the CMD instruction at runtime. When you do Docker run, you can specify a different command to run.
Let's rerun the container from the image
and overwrite the CMD instruction with echo hello Docker. See? This time it prints out hello Docker instead. The next topic we're going to talk about is Docker cache. You probably have already noticed, last Docker build is much faster than the first build. That is because Docker cache. Each time Docker executes an instruction, it builds a new image layer. The next time, if the instruction doesn't change, Docker knows the image layer already exists, rather than building it again. Docker will simply reuse the existing layer.
As you see, the last Docker build does not redo step 2. It just reuses the image built previously.
This helps to make our build much faster.
If you're building many containers, this can greatly reduce build time. However, if Docker cache is used too aggressively, it may cause issues.
For example, say you have a Docker file like this. After building the image, all layers are in the Docker cache. Suppose you later modify apt-get install by adding extra package curl.
Docker sees the first and second instruction are not changed and reuses cache from previous steps. Because the apt-get update is not run, you can potentially get an out-of-date version of git and curl.
The solution is to chain the apt-get and apt-update command as a single instruction, so that whenever the apt-get command is modified, the whole instruction will rerun to ensure you get the latest version of the package. You can also tell Docker to invalidate cache by using the no cache flag when issuing the Docker build command. Next, let's talk about copy instruction. The copy instruction copies new files or directories from build context and adds them to the file system of the container. Let's see this in action. Here, we add abc.txt file in my current directory. Let's modify the Docker file. Remove the CMD instruction and add a copy instruction to copy the abc.txt file to the container. Then save the file. Just rebuild the image and run the container. Let's enter the source directory. See? We get our abc.txt file. There's another instruction which is very similar to copy. That is the add instruction. Those two instructions are quite similar. The difference is that add can do more magic. Add allows you to download a file from internet and copy to the container. Add also has the ability to automatically unpack compressed files. If the src argument is a local file in a recognized compression format, then it's unpacked at a specified test path in a container's file system. Generally speaking, copy is preferred. That's because it's more transparent than add. Copy only supports the basic copying of local files into the container. Copy is really just a stripped-down version of add. Ultimately, the rule is this: use copy, unless you're absolutely sure you need add. I hope you have enjoyed this lecture. I'll see you later. Hello, welcome back. Previously, we have learned how to build a Docker image, either by manually committing the changes we made in a container or by writing a Docker file. In this lecture, we'll see how to push our extended images to a Docker repository so that other developers can use that image, or we can pull that to our production environment and run it as a container. The easiest way to make your images available is to use the Docker Hub, which provides free repositories for public images. First, we need to create a Docker Hub account. Let's go to Docker Hub, where you sign up for your account. Just type your Docker Hub ID, email address, and password. After you have signed up and you have logged into your account, it looks like this. I just created a Docker Hub account for this tutorial. JLead tutorial is the Docker Hub ID. In order to push the image to the right repository, we need to associate the image with the Docker Hub account. The way to link the image with the Docker Hub account is to rename the image to something like Docker Hub ID/repository name. The command to rename this image is docker tag. Let's see this in action. First, we issue Docker images command, which displays all the current images in my local box. The image we're going to push is this extended Debian image. Now let's rename this image. Just type docker tag, copy and paste the image ID. Then the repository name, jetutorial/Debian. We also need to specify a tag for this image. If we leave it blank, Docker will just use the default latest tag. But try not to use latest tag unless you have to. Let me explain why. Docker will use latest as a default tag when no tag is provided. But beyond that, the latest tag has no special meaning. A lot of repositories use it to tag the most up-to-date stable image. However, this is still only a convention, and is entirely not being enforced. Images which are tagged latest will not be updated automatically when a newer version of the image is pushed to the repository. If you're shipping Docker images to a production environment, you should just ignore the latest tag. Don't use it, don't be tempted by it. It's easy to look at it and think that your deployment script should just pull latest. However, this is not enforced. It takes a lot of discipline to make that work. The safest way is just to version your tags every time. Here, we just explicitly specify tag 1.01, then hit enter. Now let's do Docker images again. See, the image has been tagged with a new name. The first and the second image have the same image ID. Because they're the same image and have exactly the same content, but tagged with different names. The next step is to push the image to Docker Hub. In order to do this, we need to issue the command docker logging. We'll need to type our Docker Hub account credentials. Now we're logged in. Finally, we can do docker push, followed by the repository name and tag. And hit enter. Now it is sending the image to Docker Hub. This is 250 megabyte image, which might take a while to push. I'm fast forwarding the video until the image has been pushed. This is what you will see if everything worked out successfully. Now, let's go back to our Docker Hub account and refresh the page. We can see the new image appears under my account. Now we can click the image and check the image details, such as image tag. And that's it for this lecture. I hope you've enjoyed it. In this lecture, we're going to talk about Docker image layers. A Docker image is made up of a list of read-only layers that represent file system differences. Image layers are stacked on top of each other to form a base for the container's file system. Take a look at this diagram here. Each image consists of multiple layers, and each layer is just another image. The image below is referred to as the parent image. We call the image at the very bottom as the base image. Docker is pulling the images layer by layer. You can also check the full set of layers that make up an image by running the Docker history command. As you see, BusyBox image consists of two layers. The base layer is to add a file, and the second layer is to run bash. When we create a new container, you add a new, thin, writable layer on top of the underlying stack. This layer is often called the writable container layer. All changes made to the running container, such as writing new files, modifying existing files, and deleting files, are written to this thin writable container layer. The major difference between a container and an image is the top writable layer. All writes to the container that add new or modify existing data are stored in this writable layer. When the container is deleted, the writable layer is also deleted. The underlying image remains unchanged. Because each container has its own thin writable container layer, and all changes are stored in this container layer. This means that multiple containers can share access to the same underlying image, and yet have their own data state. The diagram shows multiple containers sharing the same Ubuntu 15.04 image. In this lecture, we'll learn how to build Docker images. There are two ways to build a Docker image. We can either commit our change made in a container to make a new Docker image, or we can write a Docker file to build an image. In this lecture, we'll start looking at the first approach. Here is what we'll do in the lecture. Firstly, we'll spin up a container from a base image. Secondly, we'll install git package in the container. Finally, use Docker commit command to commit changes made in the container to build a new image. Let's see this in action.
This time, we'll be using Debian Image, which is one of the most popular Linux distributions. Here, we're at the Docker Hub website. Search for Debian.
Let's pick tag Jesse.
As you see, Debian is also a relatively small image, which is about 125 megabytes and consists of two layers.
Open up our terminal
and type docker run-it debian jesse.
Since Docker can find the image locally, it is pulling from Docker Hub. I'm fast-forwarding the video until the download is done. Now the image has been downloaded, and we're right inside the shell of the container. We can do ls command to show the root directory structure of the container.
As you see, it is typical Debian file system.
What if we want to use git command here? Just type git. Oops, looks like git is not installed in this container. Let's install it by using the apt-get package management tool. Here we do apt-get update and apt-get install -y git. We put -y here so it would automatically confirm yes to prompts. Now, as you see, it is installing Git. I'll fast forward the video until it is done. Now it has installed the Git package. Let's verify Git has installed correctly. First, we clear the screen and type Git again. See? Git shows me the help message. What I will do now is that I'll exit the shell and we're going to commit our container as a new Docker image. We have a new command to learn. That is Docker commit. What Docker commit command does is to save the changes we made to the container's file system into a new image. When running this command, we specify the ID of the container we're committing and the repository and tag of the new image. Let me show you in a second. Here we do docker ps-a to get the ID of the container we just run. Then we commit the container by running docker commit. Just copy and paste the container ID here. Next, we need to provide the repository name and image tag.
For the repository, I'll put my own Docker Hub repository name, which consists of my Docker Hub user ID, James Lee // and the official Debian repository name.
And we'll tag the image with 1.00. Then hit enter. Docker commits our changes to a new image and returns the long ID of the new image. If we do Docker images here,
we can see our new image, James Lee Debian,
and tagged with 1.00.
It's a little bit bigger than the official Debian image because I extended the file system.
We have learned previously, images are made of the file system layers.
The base layer of this new image is Debian.
And we have extended the base image with a new layer, so it takes a bit more size on disk. Here we can spin up a container based on this new image. Now we're in the shell of the new container. We can do ls command to show the file structure. Let's try the git command here. See? The git command has already been installed. The changes we have committed are persistent in the new image. I'll see you later.